Okay, I think we should get started. So welcome everybody to BAC 307, the Cold Data Playbook, building the ultimate archive solution within Amazon Glacier. My name is Colin Legier. I'm the GM of Amazon Glacier with Amazon Web Services. Joining us later is going to be David Rosen. We're very lucky to have him. He's a VP Solutions Architect from Sony with Sony Media Cloud Services. So let's go over what we're going to cover here today. So on the agenda, we're going to start off with defining what archival is, making sure that we're all on the same page in terms of what workloads are appropriate for archival, sorts of workloads that people sometimes conflate with archival, confuse with archival. We're going to get into a couple of specific a couple of specific industries that have deep archival workloads, and also some workloads that are sort of cross-industry that you might have in your world. I'm going to go over Amazon Glacier, how that plays into it, how it compares to some traditional approaches. And then finally, we're going to get into best practices. I'm going to go over about 3 or 4 best practices that we've culled from customers who've basically been trying to solve some specific archival issues and how they actually accomplish that with Glacier. What are some of those best practices that you can apply to a system you might be building or designing? And then I'm going to turn it over to David, who's going to take us through a deep dive with Sony MCS and the work he's done there. So let's first off dive into what is archival. And one of the best places to start it with defining it in this particular case is really defining what it isn't. And so one of the key things that folks tend to conflate, or 2 key use cases folks tend to conflate that are really quite separate, are backup and archival. They're often sort of said in the same sentence, backup and archival, but they're really 2 very, very different workloads. So when you think of backup, what I want you to be thinking of is data that's needed in the near term for business continuity reasons. So when you're building a backup application, you're typically thinking about things like your recovery time objective, or your RTO. So how quickly can you get the backup back into primary storage and useful in the case of a continuity issue? How fresh is the data? What's the recovery point objective, the RPO? Issues like this, that data tends to be very short-lived, is one really big characteristic of it. So you can imagine here in a common scenario we're probably mostly familiar with at least some variant of. If you're doing, say, daily backups of a data set, yesterday's backup is incredibly important. The day before that is still useful, but maybe not as important. By the time you get maybe 7 days out on a daily backup, that data's lost a lot of its value, and you're probably deleting after something like 7 days. So data rapidly declines in value in a backup world. Archive, in contrast to that, tends to be very long-lived. So you're looking at data that lives for quarters, years, maybe even forever. Data where that value is maintained for the long term. You could be doing this data for continuity reasons, for compliance reasons, holding on to it for regulatory reasons. Could be that you're just pulling it off to the side in case you need to refer to it back in the future. But the big key thing there is to think about data that is going to live for a very long time and maintain its value over time. So let's dive into some specific cases to kind of ground that and give you some examples of these sorts of archival workloads. So the first one, and David's going to be talking about this one in a little bit more detail towards the end of the presentation, the half of the presentation, is media. So I'm going to kind of skip over that one. Another great use case here would be healthcare and life sciences. So you can think of the massive amounts of data that is involved in something like healthcare and life sciences. Great examples of this might be medical imaging data. So you can imagine in the lifetime of a medical imaging data system, you're going to be producing, say, MRIs, things like that. You're going to want to hold on to that for, say, the lifetime of the patient at the very least. You'll often actually also look at holding on to data sets like that or data produced from a system like that for the working lifetime of the machine, and that can be decades. Life sciences, so genomics data, it's another great case where you have massive, massive data sets. You'll want to go back periodically to do run of analyses as new data and new sort of findings come up. Another really large archival data workload. You then get into things like financial services and regulatory workloads. So this cases, there's a whole bunch of industries where by law you must retain data for 7 years, 3 years. There's often rules that are very specific as to how that data must be maintained, how geographically dispersed it must be, things like that. Lots of data in oil and gas. And then there actually are backup use cases that would be classified as archival use cases. So I mentioned long-term backups here. So you can think of cases where, again, this isn't so much your daily 7-day rolling backups, but you'll have cases where you'll want to keep a backup maybe, say, on a every couple of week periodicity or monthly periodicity forever for a very long time. The idea being that if any sort of corruption or loss due to a bug or something like that creeps into your data set, you can then go back and look at those point-in-time snapshots that you've kept long-term do some forensics, and reconstruct your data. So this is sort of more of a disaster recovery, for a long-running bug kind of scenario that you get into there. And then another huge data set that almost every industry, almost every sort of system has would be log data. So this includes everything from application logs to things like user data, clickstream data, anything you'd be doing analytics or forensics on at a later date. So if we look at sort of the underlying properties then that go across all those various data sets, they have a number of things in common. The first one is that it's in an archival world, that copy that you're storing in your archival system is often the only copy in existence. So durability is a really key thing. If that data gets lost, if that data gets corrupted, there's nowhere else to go. It's sort of your last line of defense for preserving that data. So a really, really key thing to consider when you're looking at an archival system is the durability of the data. Another thing is that the data is often very highly sensitive. Again, if it's worth keeping around for a long time like this, it's often because it has some deep connection to the business. So in the media world, that could be actually your core assets, right? You're producing a film, producing television, doing something like this. This is maybe something you're going to want to reissue, refer back to, resell. It's actually what you spent all the money, the millions of dollars actually producing. It could be in something like the healthcare industry that it's actually highly sensitive. So if you're to lose this or if it were to leak, you could imagine that there'd be HIPAA violations there in say, the healthcare industry. So security is a really key focus of these sorts of systems. And then once you sort of passed go on that, once you have your durability and once you have your security in place, the next thing to worry about really is storage cost. So these systems tend to be very highly optimized for storage cost because they tend not to be accessed all that much. Right? This is often where you'll hear this data referred to as cold data. Right? So this is data that's long-lived, rarely accessed, and so you can often trade away the sorts of throughput and the sorts of latency performance you get in a conventional storage system and really optimize the system towards that ongoing storage cost. And so, like I said, asynchronous access tends to come into play here, so it's not uncommon to see days of access, many hours of access to getting back data from a system like this. And again, sort of when you're thinking about lifetimes of data in the archival space, you want to think quarters, years, or often forever that the data is actually being stored. And then the final one that I already touched on a little bit earlier is just compliance and regulation almost always applies. So you're almost always looking at some sort of either internal standard that your company set out for how data should be stored, how it should be managed and maintained, what access is being granted to it, or even legal compliance or a set of legal compliance requirements that dictate what you can and cannot do with that data. So how do folks typically do this? What's their traditional approach? For the last many decades, probably about 50, 60 years now, the solution to this has been largely tape-based. So what folks will do is they'll plonk down $1 million, a couple $1 million in the case of some of these large data sets, buy a tape library, a tape silo, set aside some floor space for that, buy LTO tapes or DLT tapes, have a system that manages that, have specialized personnel that are handling that, and very typically it's fronted by some specialized piece of software. And the way that would work is you'd have your management software. It might be doing actually a combination of backup and archive or just purely archive. But any data flowing into that system is going to flow into your tape libraries and must flow back out through that system. So it's sort of a one-way in, one-way out sort of software solution that you'll tend to get in place there. People have a couple other variants that they'll use. Another common one in, say, the last 6, 7 years that's been fairly popular is VTL. So in a VTL system, what you have is typically an array of spinning disk, which has some software in front of it to make it look like a tape library to those same sorts of backup applications and archive applications. People will do tape out and vaulting. So this is where they'll take one or more copies of the tape that are in those libraries, stow them in a mine shaft somewhere or a warehouse somewhere, so they have some geographical redundancy. And then really there's a lot of moving parts in this and management around these, again, with this sort of capital outlays that have to sort of come with some periodicity. So what we tried to do with Glacier is really sort of get away from that model in a big way and make it just a very simplified, easy to understand, easy to use model where a lot of those key problems that I was referencing earlier were handled on your behalf. So what we provide is REST-based, HTTPS-based archiving in the cloud. From a durability standpoint, we're designed for 11 nines of durability. So what does that actually mean? So in mathematical terms, it means that if you had 10,000 archives in the system in a given year, you'd expect to lose one of those archives every 10 million years. From a practical standpoint, it also means that we can withstand a bunch of threat vectors that are always sort of creeping in to try and get at your data. So We can handle the loss of multiple devices, multiple facilities, the system's self-healing, so we're recognizing when those failures occur and actually repairing them proactively. There's all sorts of processes throughout the system that are constantly monitoring health and doing those self-healing activities. From an access control standpoint and security standpoint, I'd actually encourage you, if you haven't had a chance to look at the AWS Security White Paper. So quite a few things that go on there to actually secure your data. So at the high level that you can actually see from the service interface, we have things like IAM policies that should define who can access various pieces of your data and under what conditions. So you get sort of fine-grained access control there that you can set up. But over and above that, there's actually quite a bit that goes into the physical access control to your data. Right? You can imagine that you don't want to be in a situation where somebody can walk off, especially if you're running sort of an on-premise tape system. Somebody could walk off with a tape. You could lose a tape, things like that. So there's actually quite a bit of physical access control that goes on within our system to prevent those sorts of situations that are outlined in that white paper. But a couple of ideas here to think about. People who have physical access to the data center, it has to be a business need for them to actually go in. Those folks don't actually have logical access to the data, so they can't do anything with the actual device once they're in there. There's multi-factor authentication, trying to get, if they actually want to get in to where the equipment is, they have to pass through multiple security checks to actually even get access to equipment. A whole slew of activities that go on there that we have various controls over and compliance certification around. Aside from that, aside from the security story, which again I encourage you to check out the white paper, we do quite a bit of work on data integrity. This is another really critical system here for data integrity, because you can imagine if you're sending garbage in and then storing it for 6, 7 years and then pulling it back out, you'll be quite upset. So in designing the APIs for the system, we added things like mandatory checksums, where basically any single piece of data that you send us has to have this sort of chain of custody of checksumming, where let's say on the client side, you're going to generate a checksum for the data you're sending to us, put that through to us, we're synchronously going to generate that checksum on our side, we'll reject the data if it doesn't match, and then when you come around to pulling out the data, you'll be able to see on the same side that, hey, yes, that same checksum that I put in matches what I'm getting back out, and you have that sort of full end-to-end chain of custody at all times. We're also encrypting the data at rest at all times. It's a non-optional feature of Glacier, so a bunch of built-in security protocols there. I already mentioned compliance regimes a few times. I'd encourage you to check out the website to see what various ones we cover, but people in various industries, various ones I mentioned earlier, are building compliant applications within Glacier. So the financial community, for the healthcare community, there's quite a few there that you can see some existing use cases on. From a retrieval standpoint, data comes back in 3 to 5 hours. We'll get into it a little bit later as to how actually that mechanism works and what that handshake looks like. But that's a very fast retrieval time in archival terms. I know we're not really used to that in sort of a more readily accessible system like S3, but it's a nice balance between that asynchrony as access and latency and cost there. And that ultimately is what we're trying to optimize for, is that total cost of ownership of storage on a recurring basis. So Glacier is the least expensive storage option in our portfolio at a penny per gigabyte per month. So why would you use this over a traditional tape system? So one of the big ones that I referred to earlier was just the no upfront commitment and capital costs. So again, this is usually millions of dollars upfront to build something like a tape silo. And then you're provisioning a lot of storage, but not necessarily utilizing that storage. You have to do a refresh cycle, maybe every 5 to 7 years, to actually go up to the next technology, which is going to be a long migration process that you'll have to have personnel go off and do. In our case, we're metered usage, pay as you go, whatever you're using at that given time, we're just going to charge you for that. The OpEx worries and ongoing maintenance worries when tape is avoided as well. So again, losing the tape, the mishandling it. Do you have your environmentals right? Like, is your temperature and humidity within certain constraints at all time? Tape's actually a pretty finicky beast, right? So you avoid all of that worry and all of that trouble of basically maintaining durability in a system like that. And then finally, you can control where your data is actually being stored. And this is another kind of key component for compliance, more than anything else, where we're available in 8 regions worldwide. And whenever you put data within a region, it's never going to leave that region. You'd actually have to go in and move that. We don't even have a mechanism to do that in an automated way. So let's move on to some Glacier concepts. So I just want to give you a high-level view at first of what a Glacier application would look like, or what an application that uses Glacier would look like. Because there's certain things that you may or may not expect in terms of who is responsible for what in this context. So here you have just basically a simplified view of an application that might be doing archival. On the left, what we have is the raw data just coming into the system. So this could be any of the workloads that I was mentioning earlier. Could be small files, large files, what have you. And what that application is going to do is going to have a couple of different pieces. So the first piece that application is going to have will be some sort of data collection piece. So this could be actually on the server side with the application itself, could be a remote agent that's sending stuff to the actual application, but some bit that's actually getting the raw data to the actual application. From that point, generally there's some processing involved. So what's going to go on there is the application is going to take that data, maybe extract relevant metadata from it, index it, build up some deeper view of the data for later reference and searching, things like that, and store that locally in some form of index. This could be even a local database. In the context of something like an application you might build yourself within AWS, this could be RDS or DynamoDB, anything like that. But building up to that deep metadata view. That's generally fairly specific by industry as to what metadata one might want to store, what that would look like, what are the use cases against it. So that tends to be sort of highly specific to the application. Then the data generally goes through some sort of transformation process. Since it's going to be stored for a long time, it's often very advantageous to transform it in various ways. So I mentioned compression here, but there's a couple of other things that might be going on. So the data might be deduplicated, to get it down to a smaller size, just a form of compression. Compressed, it might be aggregated with, if it's very small files, with a bunch of other files. It can be encrypted at this point. But generally, there's some sort of transformation to take it from live data to sort of data that's suitable for archival. And then once that's sort of ready and transformed into a suitable archive, that's where actually Glacier would come in as that underlying storage target. So we'd be sending, the application would be sending the data off to Glacier for storage. And at that point, it's durably stored. It'll have a reference for it in this local database. And those are sort of the moving pieces. Now, in terms of what that application could be, that application, again, could be something custom that you've gone off and written for your particular application. But more often than not, it's actually, there's a couple other variants that you'll find. One is existing backup and archival software, right? So this is one of the reasons that local index wouldn't be sort of subsumed by something like a storage target like Glacier, is because often those applications have multiple storage targets, right? And you want to have some sort of holistic view of the data, whether it's in more readily available storage or an archival storage or being transferred or migrated or maybe in multiple locations. Generally, you want to have that sort of holistic view. It could be a gateway application. That's another really popular thing we see where people put data into some sort of landing zone that might be file system based or block based. And then under the covers, that gateway is then sucking that into Glacier and leaving a reference. And then it can be later recalled for use. There's a variety of applications here, both third party and custom built that we'll see. There's a great partner and ecosystem page that you can check out on the website that outlines all the various partners that integrate with us. But it's a fairly rich ecosystem for various verticals and also just general archival storage. Another key way that people get data to us is via S3. So I'm assuming a bit of familiarity here with S3. I'm not going to go in great deal into S3, but this is a really popular option. So if you have an existing data set in S3, or if you're using a client that has existing native S3 integration that you like, or if you have any sort of data set that needs to be live for a certain amount of time and sort of readily accessible, is a very common pattern, and then is suitable for archival, this is a great option. And how this works is essentially you'd use S3 just as you would today, transfer objects into it in your bucket, and then you could set a policy against that bucket and say things basically like in the example I have here where everything in this bucket that lands here after 30 days is going to get transitioned to Glacier. S3 will basically handle that for you on your behalf, so it'll detect that time, it'll move that down, you don't have to do anything there. It still maintains the reference to it within S3, so you can still see it if you're listing your objects. And then it can be recalled and restored back to S3 for use if needed, again, in that 3 to 5 hour time window. And in this case, we're actually also automatically deleting. So after a year, in this case, that data is actually rolling off and being deleted automatically for you. So it's a very, very popular option if you have an existing S3 use case that I'd encourage you to check out. So let's get into some actual Glacier concepts of the service itself, just introduce some of the nouns and the verbs here. So Glacier storage is done in terms of archives. So this is basically the unit of data storage. It can be anywhere from a byte to 40 terabytes. To us, it's a stream of bytes. It's not interpreted in any way by the service. As I mentioned earlier, it's always encrypted at rest. It's immutable. There's an interesting handshake as to how that works. This is sort of to preserve immutability and make it impossible to overwrite, is that you stream us the data, and then we'll hand you back an archive ID to reference that data. And that'd be the thing that you'd then refer to in your local index and act against. So you could, with that archive ID handle, you could retrieve that archive, you could delete that archive. That's sort of your unit with which you have that handle to that data. And then the other thing that can go along with that is you have an optional archive description, which gives you a little bit more sort of free-form text to describe the archive. And I'll get into sort of best practices for that in a sec. So archives then are contained within vaults. So if you're familiar with S3, this is a lot like their bucket concept. But the idea with a vault is that's unique to an account, so you can name it anything you'd like in your account in your region. You can have 1,000 vaults per account per region, and every vault contain an unlimited number of archives. Vaults is sort of also the handle with which you can attach various notification policies. So we have a mechanism where when you're restoring jobs, you can get a notification. That can be set up on a per vault basis as a default. All of your access control is set up against the vault, so you can sort of think of that security metaphor, right? Anybody who can get into the vault can have access to any of the archives, but that line of security is at the vault level. So that's your organizational concept within the service, if you will. And then finally, jobs. So this is the mechanism by which we have a handshake around that asynchronous access to data. So when you're asking me back for an archive, what the service is going to do is basically hand you synchronously a job ID. It's going to take 3 to 5 hours to pull back that data into some sort of staging area. And then once that's ready and complete, you'll then be able to download the output of that job, and that'll be your original data. OK, so let's just take a quick look at what that getting started workflow might look like here. So it's a simple 3-step process to get started uploading some data. So first thing you would do is you'd actually create a vault. So in this case, we're going to create a vault called Films. And second thing you might do is here we have an archive app user. And what we'd like to do with this archive application user is give it rights to upload to that Films vault, but to do no other operations. So for instance, it couldn't delete archives. It could just produce archives into the vault. This is sort of a separation of responsibility model that one might want to do. So we set up that IAM policy on that vault to allow that. And then we can go ahead and upload archives. And again, that handshake looks like, here's the data, and I'm going to hand you back an archive. So on the flip side, retrieving data, what we're going to do is we're going to initiate a job. We're going to say, give me this archive ID to this vault. We're going to get handed back a job ID. We're going to wait that 3 to 5 hours for completion. And then once that completion notification comes through via SNS, or we could actually just poll the job as well to see when it's completed, we're going to be able to download our output. So that's basically the nuts and bolts of getting data in and out of the service. So what are some specific best practices? So this is cases where we've had a large number of customers who've encountered various issues where they found that these particular techniques have been helpful. So the first one, and one of the biggest ones that we get up front, is how on earth do you calculate TCO? And in particular, when you're calculating TCO versus an on-premise solution. So what we find there is people almost invariably, customers almost invariably miss out quite a few of the dimensions when they're calculating on-premise costs for their existing archival solution. So I'm not going to go through the list because it's fairly exhaustive here, but these are the sorts of things that you want to think about when you're actually doing this sort of analysis and comparing it to a system where all the costs are built in, like Glacier. So just to highlight a few, like the one that people commonly get right, or at least consider up front, is provision storage versus actually utilized storage. There's often huge differences there. But there's some more esoteric ones that can be more surprising, more expensive than you might expect. Things like power, cooling, space, labor, training on one of those traditional archival systems that you really should be factoring in. Another really big one is just that, again, that periodicity of capital flow, right? So you're spending millions and millions of dollars. 5 years from now, you're going to have to do that again in sort of these big waves. You have these big migrations that are going to have to go on with that periodicity. There's a lot of cost and a lot of hidden cost to that people don't consider up front. So what I'd encourage you to do with this, aside from doing this analysis yourself, is we'd love to hear from you about your analysis, go through it. We have some people who specialize in this area who can help you ask questions and basically, make sure that your analysis has covered all the key areas that it needs to, and make sure that it's more of an apples-to-apples comparison. So we're very eager to hear from you if you have one of these sorts of analyses that are going on, so we can help take you through that. Next one I want to cover is a durability concern. So I mentioned archive descriptions are optional and can be sent through on an archive upload. So one of the patterns that you want to think about there is, what about that local index, right? So we have this incredibly highly durable archival storage for the data itself, but if something goes wrong with that local index, if you're not careful, that can just be garbage, right? It can be uninterpreted archive IDs. What is this? Has no data to it. How could it be useful from there on in? So what you want to do is you want to make sure that sufficient metadata is actually reflected into our system so that if a disaster was to happen with that local index, it would be reconstructible to some degree. So I have an example here basically where we're uploading an archive, I'm sending through data, there might be some sort of archive description that I'm going to send along where I'm going to go and reflect a number of things that are in that local index, let's say the primary key, the description, in this case the department, to make sure that's actually in a machine-readable form in that archive description. So in that disaster scenario, I can reconstruct the world. There's a mechanism called inventories, essentially, with us, where you can ask for the inventory for a vault, and we'll hand you back the archive, every single archive ID, along with its description, size, checksum, in basically a big file so that you can actually do that reconciliation. So it's definitely a key thing to consider. Next is object size overhead. So again, when we're sort of optimizing a storage system for cost of storage, you have to really worry about what your input data looks like. And one of the mistakes that we've seen customers make is not really doing sufficient transformation for certain use cases to end up with a cost-effective result. So in the case where you have extremely large objects, any sort of really large archives, any sort of per archive overhead is going to be fairly minuscule. Like in this case, and this isn't even particularly large by archival standards, in the case of a 3.2 megabyte object, only 1% of your cost is going to go to this 32K of overhead that you have per archive by the system, right? So you can sort of think of this, if I'm storing 3.2 megabytes in the system, what's actually going on under the covers is we're storing 3.2 megabytes plus 32K of overhead, and you're being metered on that basis. However, let's say that I have a 1 kilobyte archive that I'm going to store. Now, if it happens to be just a single 1 kilobyte archive and all of the rest of my archives are a gigabyte, I don't really care. That average size is really big. But let's say that my average size was close to 1 kilobyte. That's going to be enormously expensive, right? That's going to be 97% of my costs going to that overhead. So you really want to look at that data transformation. So the typical technique here and the recommended technique is to aggregate your data. So again, in our 1K case, what we might do is we might decide to choose to aggregate to 16 megabyte object sizes. So we're going to put 16,000 1 kilobyte files into a single 16 megabyte archive. And then basically I get to minuscule overhead costs. The only trick there is that if you're not careful in how you aggregate, you can actually make your life a lot harder down the road, particularly if you're then looking to then pluck back a single 1 kilobyte archive or 1 kilobyte file from that archive. If you're not careful, let's say you just zipped all of those together, what's going to go on is there's not going to be any sort of contiguity in any of those files, right? It's going to be scattered throughout that overall size, and so you can't actually pull back a specific range, which is a pretty common scenario that we'll see with those really small files. You can imagine sometimes these are like contiguous time-based records, and you have some way to index into them and know, okay, I want from this time to this time, and translate that to a byte range. So a couple things you want to think about there. One is how you're actually aggregating and how you're actually doing checksumming in the case where you're aggregating. So let's look at that in sort of an example here. So it might look like this, where this would be sort of a recommended format where you have your local index off to the side. Along with storing the archive ID, you're storing the offset into that archive ID for those specific files, maybe some checksums and metadata on that basis. But then you're laying out your data much more like this, where you have a checksum specific to the file. That file contiguously, it might have been compressed but then aggregated after compression, laid out like this. And so what that allows you to do is basically pull back the block that includes both the checksum and the file. So then that's also self-referential. So you can actually say, okay, none of these bits were shifted. Basically because the overall archive is going to be the overall checksum for that archive is going to be really referring to that, not to that specific file. So you're able to sort of maintain integrity there. Another key practice is looking at your data ingestion options. So for most folks, the internet's going to be great. You're going to be able to get sufficient throughput for that. We recommend you use HTTPS, but that'll be cost-effective and a worthwhile approach to just send us data over the good old internet. For folks who have good sustained workloads, though, very high bandwidth workloads, want some reliability or greater reliability in terms of the pipes to us, we'd really recommend you take a look at Direct Connect. So this is where we have data hotels all over the world. You can get a direct connection to us, and basically that'll give you a more reliable and often less expensive connection for those sustained data loads. And then finally, there's the import-export service. And so this is a great service for cases where you have maybe a backlog of data that you need to send to us, but don't really have the ongoing sustained workload that would require you to bump up your connection and add a number of direct connect points. So it's a great sort of for that bootstrapping case. And then the final best practice I want to go over before handing over to David here is multi-part upload. So this is a really key thing for a number of things in your system. So one of the problems that we run into on a regular basis, or the customers of ours run into on a regular basis, is that HTTP and HTTPS is not really a great protocol. It's a very widely adopted protocol, but when it comes to data transfer, there's actually all sorts of problems with it. And one of the ones that gets hit fairly regularly is that if you're sending us extremely large files, right, so think again like hundreds of megabytes, gigabytes, bandwidth for an individual connection, throughput for an individual connection tends to decay over time. And so you're never really able to really efficiently utilize your pipes if you're just sending a single large archive through a single HTTP connection generally. Now there's accelerator products that'll do a great job of tunneling for you and doing that. Making sure that you're efficiently utilizing those pipes. But another really great technique for that that's built into the service is multi-part uploads. So it's basically a three-step process. You'll call and initiate a multi-part upload call on us. You have to specify a part size up front. So this could be 16 megabytes, 32 megabytes, something like that range is a good choice. And we'll hand you back synchronously an upload ID. You'll then upload your parts. broken into those, say, 16 megabyte chunks. And you can do that with many parallel workers. Sort of, you can do a little bit of tuning here, but you can basically, with enough parallel workers operating on enough parts, be able to really fill up that pipe to us and get very efficient utilization to us. So it's great for throughput. Another thing it's great for is reliability. You can imagine if you're transferring 200 gigabyte files or something like that to us and something goes wrong with that connection, you don't want to have to restart that all the time. So nice thing about this is you can restart on a part-by-part basis, get better reliability through that. And then finally, the other thing it can get you is item potency. So this is maybe a little bit non-intuitive, but you can imagine that data handshake where you're sending us data and we're sending you back an archive ID. You don't really have any upfront breadcrumb from us in that model that you know that agent is working on that work. So you can imagine if you have two agents that are both trying to upload the same archive, they both stream that identical data to us and they both get back an archive ID. You've essentially done double the work, and neither of those agents really had any idea that the other was operating. So to give you some hook, also, let's say that a single agent was doing an upload and then failed during that archive upload, you'd have no ability to then, know, did that happen? Did that not happen? Can I restart this work? You have sort of no hook there. So that's another common use for multi-part uploads, where basically by getting that upload ID, you can associate that upload ID with the key for the archive you're trying to upload, and use that essentially to lock that work from other agents, or to coordinate that work across other parallel agents if you're doing that. So you can get that item potency effect. So one could imagine here that you're initiating an upload, get back that upload ID, I'm putting that entry into my index, other workers are seeing, oh, okay, that entry already has an associated upload ID that's already being worked on, and then I have my agent do that upload, complete the upload, get back an archive ID, and I've only done one transmission instead of accidentally doing multiple transitions. So I hope the best practice was helpful. I'd like to bring up David Rosen to take us through Sony.
Great. Thanks, Colin. Excellent presentation. I've been working with Glacier and S3 for a couple of years now, and I learned a lot, so thanks for that. Two key gems, though, that I took out of it, which I don't know if they were your intent. Two new words, for me anyway: periodicity and contiguity. Love them, and I'm going to try to work them into this presentation as many times as I can. Hi, guys. I'm David Rosen with Sony Media Cloud Services. For those of you who aren't familiar with Media Cloud Services, we are a company within Sony that was started about 2 years ago to help bridge the gap between software and hardware. So Sony obviously makes some fantastic cameras and equipment that is used in the creative process when making movies and television content, et cetera. And on the far end of the media life cycle, Sony's also got some fantastic distribution capabilities. And there's really some tools in the middle that hit specific workflows. But with the advent of the cloud, we saw a great opportunity to sort of tie the capture of that content into some of the creative workflows in a much more intelligent way. So hence Sony Media Cloud Services, which is ultimately a SaaS to help creative professionals capture, manage, share, and collaborate around content. Our flagship product is C, and it's CI, which for those of you that weren't aware, as I wasn't, there apparently are cloud classification symbols, and that's the one for Cirrus Clouds. So now you know. Wikipedia, I looked it up, and it in fact is true. I thought it was just a marketing thing from our folks so they could say things like, see the possibilities, see your media. But in fact, it's a real thing. So C is basically a media collaboration platform which allows people to upload their content, organize it, share it, and work with it. And so the customers that we have do all sorts of different things, and some of the examples are up there. It's certainly just a subset of them. But ultimately, they're putting content into a central location so that they can quickly get it to people, share it, get it in front of them, and start getting feedback that they might need. But more and more, what we found is that all of the various customers that we're having are wanting us to start looking at the full life cycle of the media, right? So not just the capture and the content and some of the early work in progress stuff, but how can we keep that around for a long time so that we can get back to it later and open up additional revenue opportunities potentially. And that's where archive has started to come in. It wasn't originally on our roadmap of things to do. It's one of those things that just sort of evolved as a result of customers working with us for a long time, generating this content, and then thinking, maybe it's worth keeping. So we've got lots of different types of customers, or folks that use us in slightly different ways, right? And specifically, I'll focus on those that have come to us for archive needs. We've got our basic workspace users. Those are guys that are using us to get stuff done, upload the content, share it. They're using our rich video collaboration tools or some of our ideation tools. And then they end up with this big repository of content that they never had before, and they say, that's worth keeping. What can I do? And then we've got others that leverage us just for our CAPI. They build their own applications to do whatever they need to do with media, but they don't want to focus on the heavy lifting on the back end, things like having media management, knowing how to transcode MXF files, and deal with those sorts of things. So they leverage us for our ingest pipeline and for our media management capabilities. And then the third class of customers that have been looking for archive solutions are those folks that they've got a lot of files sitting on spinning disk and a lot of the infrastructure scenarios that Colin was talking about, where they've got tape and net backup and all kinds of good stuff in the mix, and they just need to determine, are we going to keep investing in that, or is it time to move off to something else? All of them are dealing with the same challenges, right? So the creative drivers that are forcing them to kind of look at things differently are the fact that content is getting bigger, much bigger, and there's a lot more of it. We went from HD to 2K to 4K, and now we've got things like HDR, or high dynamic range, which is ultimately just going to mean more bits in every frame. And the facility with which one can just shoot digitally now and not have to worry about changing tapes means that people are shooting a lot more. So we've got more files and bigger files. And then from a business driver perspective, people are now finding, content owners are finding that there is a lot of value in some of that content that otherwise was not used before, and it was just sitting on tape somewhere. So they want to keep that around, and they want to be able to access it so that when opportunities do arise, they're able to take advantage of it. So let's take a look at an example customer. This is a real customer of ours, and we'll talk through kind of what challenges they were facing and how they came to actually use Glacier through C in order to meet their needs. And this is a customer that really falls into that kind of double whammy situation where they've got lots and lots of files, they're huge files, and they've got this exponential growth curve as a result of the situation that I mentioned earlier. And they also use this for some of the workspace uses, which is how they kind of came to know us. So it's a very large media company. Their files range in size all over the gamut, between a meg and 250 gigs. They've got about 2.5 petabytes of content right now that is active, meaning that at any point in time it could be accessed. They do have a lot of good analytics around their content that says, hey, after 90 days, 80% of these files aren't ever touched again. Or they're not touched at any regular periodicity. Is that right? Thank you. So they've got that analytic, which helped them kind of understand whether or not they would be running into any serious issues if they had to restore a lot of data all at once. And it was not an issue for them, as evidenced by that last bullet, which is they restore about 4% of their archive every month. From an infrastructure perspective, they're 100% on-prem. They've got their custom DAM already built. So if we think back to Colin's slide where he had raw data and then he had an application that does something and then he had Glacier, they've kind of already got the application which is managing that raw data, right? What they need is something to help transition it off into Glacier. They're 100% on-prem, as I mentioned, I think. They've got Isilon for scale-out NAS, which works very well, but adds up, especially when you've got exponential growth curves. They use net backup, and they've got a petabyte tape library where they were literally running out of tape slots. From a growth standpoint, this line graph shows what they projected their storage to be. So if we look at FY13, which is when they started looking at this, they were under 2 petabytes, I think about 1.5 petabytes. they're expecting that this is going to double since just last year, and then by FY18, they will have 12 times as much data as they had at the beginning of this in FY13. So they've got a serious storage problem on their hands. And this is not including the files such as the raw files or the masters. This is literally derivative content, for the most part, marketing materials, et cetera. So imagine what that growth curve looks like when we're dealing with the true raw files that are coming off of cameras, et cetera. So these guys were very good about wanting to understand, what the TCO was. So, they went through a process of evaluating what all of those costs were. I don't know that they covered every single bullet on that slide that Colin had up there, but they certainly did cover a lot of them, and I was impressed with the amount of data that they had. And the slide sort of speaks for itself, but I'll just give you a couple of notes that you can't see in the slide. One is that they calculated that their average annual cost per gigabyte for content stored on disk was about $600 a year. And same cost on tape annually was about $300 per year. And so that's important to remember, and I think it's key that you encourage people, Colin, to actually do this analysis, because I run into people all the time that tell me, well, I can get a tape for 20 bucks. That doesn't tell you half of the story, right? Let's not even talk about the hardware involved. Just think about the people involved, and not to mention, tape refreshes that are happening when you go from LTO4 to 5 to 6. There's a lot of things that need to be taken into account, and I do think that people are starting to get that picture, but it's important to always remember that there's a lot that goes into archiving. So I know Colin and the rest at AWS would probably flog me if I didn't mention, but it is important to note the difference between the pink line and the yellow line. The yellow line is what we calculated the cost would be if we are leveraging Glacier, which in fact we are. And the pink line is if they were going to reinvest in or continue to invest in their on-premise infrastructure, right? So they accounted for things like they've got certain servers that have a useful life left of 2 years. During this period, they're going to have to be refreshing them. They're going to have to expand their tape library, all kinds of good stuff. And so I think we were looking at about $6.5 million in FY18 that it would cost to maintain that archive. And using C and Glacier, it would be just over $2 million. So pretty significant cost savings. So let's take a quick look at what the workflow looks like. And I almost was embarrassed to put this up because it's so very simple. And there's not a lot to it, so I'm going to speak very slowly and try to use up the last couple of minutes so that you don't feel ripped off. But ultimately, it's very simple, right? The client gets their content to us, and they can do that in a number of ways, as Colin mentioned. In this particular case, they happen to have a pretty large Aspera infrastructure on-premise, and we also have Aspera on demand within C. So they transferred the files via Aspera to their own S3 bucket. With every file, every Essence file that they sent us, they also included a small JSON file which had some key metadata that they wanted registered with those assets. The most important piece of metadata there, obviously, is their own unique identifier, because that was going to be key in helping them tie that back to their own application. Because remember, they had their own DAM already, and their users are accessing that content through it. But when something was archived, they're going to be able to need to access that file through us and restore it so that it can then be downloaded or previewed. So what we do is when we find those JSON files, we make sure that the actual Essence file is there, and then we copy it to an archive bucket on S3 that has a lifecycle policy on it. And it's a one-day policy, and that gives us just enough time to run it through our ingest pipeline, register it in C, and then update the status on those records so that through our API, they could always find out, oh, this thing is archive in process, or it's done, which means everything's good, and more importantly, I shouldn't try to download it without doing a restore first, okay? And I'm gonna have to race through this because I think we have a hard stop in 22 seconds, okay? And then at the end of it, every day we give them a daily report, which shows them basically everything that was archived. We tie in their unique identifier with ours so that they can do the reconciliation on their side. And as part of that ingest pipeline, by the way, we were ensuring that the checksum that they gave us matched what we calculated. So that whole chain of custody is very important, as Colin mentioned, and we make sure that that happens. From a restore perspective, now they've got the reconciliation. They've updated their own application with the C asset ID, and that is tied to their own. And so it's a very simple manner. They can identify if something is archived. It's make a single call to our API, which is just basically passing that through to the S3 API, which is going to do a restore from Glacier. We're managing the status from an application layer perspective. And then when that's done, they have the ability to download it or send it to somebody or do whatever they're interested in. So kind of forward-looking what's next for us, we see some other opportunities to integrate Glacier workflows into our application. Within our workspace application, which is where people can organize their content and share it and work with it, it's really project-based. So one of the things that we're hoping is that we can offer the folks the ability just to wrap a project, and when they're done with that project, go ahead and stick that off into Glacier so that they can maintain the content, but at a much lower price point. And that's going to help us expose our catalog experience, which is going to give advanced search capabilities and kind of content segregation so that you can use your files for appropriating audiences in different ways. And then auto-restore into our media boxes. When we send content to people, that only is going to work if the content is available. So we want to tie the ability to auto-restore a piece of content or a bunch of content that people are trying to send out. And then we're also interested in investigating AWS storage gateways. So for those folks that have a lot of content on their infrastructure and on a regular basis, they just want to use us as a kind of offset DR so that content would constantly be flowing into Glacier from their own environment. We also are interested in integrating with certain HSM vendors. We've had some conversations where they can just see us as a separate storage location. And important when I say see us, I mean the combination of C and Glacier, right? So C adds the functionality of being able to be a rich media collaboration platform so that you can manage that content, but all of the storage management under the scenes is being done through AWS S3 and Glacier. And then we're interested in kind of getting a little bit more granular as opposed to just saying anything in this bucket after X period of days needs to be sent to Glacier. Can we do things that are more commonly used in other HSM solutions like, if this content hasn't been touched in 2 months, then go ahead and archive it, things like that. So that's really the sum total of what I had to say. I didn't get the congruity word in. I didn't get that in, but I did get periodicity, and I feel like that's a win. So anyway, that's all I have to say. Thank you guys for your time. I appreciate it.